People often talk about the cloud as an invisible, bottomless hard drive, but underneath the abstraction, there is always physical hardware. For modern applications, relying on localized hard drives creates a massive operational bottleneck. When data volume scales exponentially, traditional storage arrays quickly hit a hard physical limit. To survive that volume, systems require storage architectures built from the ground up to scale infinitely, dynamically adding capacity behind the scenes without the user ever worrying about a physical server rack. This is where Amazon's Simple Storage Service, or S3, comes in. It serves as the infinitely scaling operational backbone for the entire AWS ecosystem. To see exactly how an architecture holds petabytes of data without failing, we have to look past the top-line abstraction and deconstruct it down to the atomic level. Traditional file systems use hierarchical folders, files nested inside directories. S3 uses object storage, a flat architecture where every piece of data exists independently on the exact same plane. Each individual file in S3 is called an object. The core component of that object is the body, which contains the raw data itself. The system allows an object's body to scale up to 50 terabytes. However, if you upload anything larger than 5 gigabytes, S3 requires a multi-part upload, breaking the file down into manageable chunks to ensure the network transfer succeeds. Attached directly to that body is the metadata. These are simple text key-value pairs that describe what the data actually is. Next, S3 applies tags. An object can hold up to 10 key-value pairs used to assign security permissions or manage lifecycle rules. Finally, if versioning is enabled, the object receives a version ID. Stacking iterations of the same file with unique identifiers prevents accidental deletions. By encapsulating the raw data, metadata, and security controls directly within the individual object, S3 removes the constraints of local hardware directories entirely. These flatly structured objects are housed inside containers called buckets. Each bucket requires a globally unique name across all of AWS and is tied to a specific geographic region. Grouping objects this way allows S3 to replicate them across multiple availability zones, delivering its core architectural promise: high durability of 99.99999999%, known as 11 nines. To see what that abstract percentage actually means, let's look at this visualization plotting exactly 10 million individual dots, representing objects stored within an S3 bucket. At 11 nines of durability, you can on average expect to incur the loss of a single object once every 10,000 years. It is important to separate this durability from availability. Durability means the data is never permanently lost. Availability measures how readily you can access it at any given moment. For example, standard S3 boasts 99.99% availability, meaning the service might be inaccessible for about 53 minutes a year. With petabytes of data distributed securely and redundantly, this specific level of mathematical certainty is the reason large enterprises trust their digital operations to AWS. Reaching that cloud scale presents a severe logistical challenge. Pushing petabytes of existing on-premises data into S3 requires bypassing the bottleneck of local network speeds. For massive local data migrations, AWS provides physical solutions like AWS Snowball. Snowball utilizes highly secure, ruggedized storage devices to transport data physically. Instead of saturating a digital network connection for months, you load your data onto these edge computing units and ship them directly to an AWS facility. For operations requiring continuous integration rather than a one-time migration, there is AWS Storage Gateway. This service acts as a hybrid bridge connecting your local office to the cloud. It allows on-premises applications to seamlessly access and interact with files, volumes, or virtual tapes stored directly in S3. True scale in data infrastructure requires both the raw capacity to hold the information and the engineered pathways to access it efficiently from any location. Because of its reliability and accessibility, you will find S3 integrated directly into countless other AWS services, acting as the foundation for everything from database staging to global content delivery networks. This chart illustrates the AWS shared responsibility model. AWS handles the security of the cloud, meaning it secures the physical infrastructure, servers, and network. The user is responsible for security in the cloud, managing the data, tags, and access policies themselves. That is the complete data journey. Information crosses hybrid digital bridges or physical devices, enters a globally unique bucket, and is broken down into encapsulated, durable objects. By mastering the anatomy of those objects and the math behind their redundancy, cloud architects decouple their data volume from the limitations of local hardware. Best of luck as you continue exploring these concepts on your path to earning your foundational certification. Keep building.